In this video, I'm going to demonstrate how to use the dash and wedge notation to represent three-dimensional molecules on our paper. So once again, I want to remind you of the notation we're going to be using. So this colored in dash indicates an atom or a bond that's pointing out of the page, so towards you. And this wedge structure here, or this one with the dashes, means it's pointing into the page, so away from us. So I have a few examples here of our trigonal bipyramidal geometry, and basically we're going to see what happens to the 3D structure as we add more lone pairs, replace bonds with lone pairs, and also we're going to see how to represent this on the page. So let's get started here. So we have PCl5. I've pre-drawn the lowest structure here, and I've omitted the non-bonded electrons around the other atoms. So I'm mostly interested in the number of bonding pairs and lone pairs around the central atom here. So there are 5 bonding pairs and no lone pairs, so we're looking at a trigonal bipyramidal geometry. So the way to represent that is the following. So we know we're always going to draw our central atom first, and we're going to draw the 2 axial chlorines. So now we have to draw the other 3 chlorines, which we know if we were looking down on it would look kind of trigonal planar, kind of like I said before, like the fidget spinner. So what we're going to do is we're going to draw one of the chlorines in the page. And now we have to represent that one of the chlorines is going to be coming out of the page towards us, and another one is going to be pointing back. So once again, the way to do that is like so. So here is our chlorine pointing out of the page, and here is our chlorine pointing into the page. So this is able to show the 3D structure of this molecule. Now we're going to move down to the next example. So this is sulfur with 4 fluorines attached. So the number of bonding pairs is 4. You can also see there's a lone pair here on this sulfur. If you don't know how to draw these Lewis structures, I'm going to refer you back to the other videos. So once again, the number of lone pairs is 1. So for this configuration, we're going to assign the seesaw geometry. So basically what's happening here is that, say it's very similar to the one above, except that one of these one of these equatorial atoms is going to be replaced with a lone pair instead. So let's draw it. So we'll start the exact same way. We draw our central atom. We're going to draw the axial bonds. So here are the 2 fluorines. So this time we're going to omit this chlorine. So we're going to show that one of the fluorines is coming out of the page towards us, and one of the fluorines is going into the page, and this is our seesaw structure. So typically what's you can try to visualize there would be a lone pair here in the page, and these 2 things would be coming towards us and away from us. So that's how we represent our seesaw structure. It's typically not drawn this way, but if you want, you can think about kind of like this. So there's a lone pair there. So let's move on to the next one. So what we're looking at here is a chlorine molecule with 3 fluorines bonded to it. Here's the Lewis structure that I have pre-drawn. So the number of bonding pairs is 3, and the number of lone pairs is 2. This is going to correspond to a T-shaped molecule. So basically what's happening here is yet another equatorial bond is being replaced with a lone pair. So let's draw that. Okay, so once again we start with our central atom and our two axial bonds. But this time, since the 2 lone pairs, are omitted in the drawing, what we're going to do is just draw our 3rd fluorine in the page. So T-shaped molecule is kind of a flat molecule, so there's actually no wedge dash required here. But once again, if you were to think about it, there would be 2 lone pairs, one pointing into the page and one pointing out. So they're here. They would be in the configuration of these 2 fluorines up here. So one will be pointing towards us and one will be pointing away from us. Okay, and finally let's look at our IF2- molecule, which I have drawn here. So there's 2 bonding pairs and 3 lone pairs. And this molecule is just linear, so the way to represent that, we can just do it flat on the page once again. And once again, this is a kind of a limited case of this, so all of the equatorial positions were replaced here. And now we just have the 2 axial bonds, so you can kind of think about this flip the other way. Say it's just like the PCl5 up top, but it's kind of just like this. But, you know, conventionally we don't draw it that way, so what we're looking at is this. So yeah, I just want to reiterate that all of these molecules have 5 electron groups, basically, but differing number of lone pairs. And that's why we see these different geometries.